Okay, probability and statistics. Prob and stats. That's why we don't say the word statistics. 2. We are going to work with scatter plots this time. Okay, so when we are dealing with scatter plots, we have stuff called bivariate data. It is data. Oh my goodness, that's for bad writing again. That involves two quantitative variables. Okay, bi is two, variate is variables, and deals with relationships between those variables. So, and deals with relationships between those variables. So it's going to be two things that we are talking about happening at kind of the same times. And when you plot this, you're going to get a scatter plot. So a scatter plot is a graph to help us visually compare. Oh, I hope you can spell because you can't read my writing. Data and identify possible relationships. Now, up until now, every time we have graphed an equation, we've had one variable, y equals mx plus b. Okay, it's like two variables, sorry. We have a dependent and an independent variable. You input one and you get out the other. This is going to be a little bit different. So this is just going to be two things that are happening at the same time. So we have got this little information here. Following is 10 years of data showing jeans and shirt sales at a discount store. Use the information from the table to make a scatter plot. Use a scatter plot to describe the association between the sale of the jeans and the shirts. So we're going to let what we usually call the y-axis the shirts, and we're going to let what we usually call the x-axis the jeans. Now, we've got 10 years, but that's not where we're going with this. We are going to look at our jeans. We've got to plot 46, 50, 42, 55, 35, 39, 46, 47, 50, and 62. So in our jeans, we want to look, our smallest number that we have is 35, but that's just not a good number. So let's start at 30, okay? So we're just going to start right here at 30 on the jeans, and then we're going to count by 2. So that's 32, 34, 36, 38, 40, 42, 44, 46. How high do I have to go? Looks like 62. 48. My mind is gone. 50, 52, 54, 56, 58, 60, 62. Okay. For the shirts, we go from, what's my smallest number in my shirts? 32. And we're going from 32 to my biggest number is 63. Now we don't have as many little jobberdobs here. So let's start at 30 again. And can we count by 2s? 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54. Nope. So let's count by 5s. So we have 30, 35, 40, 45, 50, 55, 60, and 65. So we just have to kind of figure out what we can fit on there. We probably could have done our jeans by bigger numbers than 2 because we have a lot of space, but that's okay. That's okay. All right, so here's what happens. In year 1, we sold 46 jeans and 32 shirts. So go to 46 on the jeans and up to 32 on the shirts. You're just kind of estimating. It's between 30 and 35. For year 2, 50 jeans, 47 shirts. There's 50 jeans, 45, 47s, right about there. Year 3, 42 jeans, 63 shirts. 42 on the jeans, 63 on the shirts. Year 4, 55 for the jeans. We sold 52 shirts. So 54, 55. Oh, this is 54 right here. So 55, sorry, can't read this. 55 on the jeans, 52 on the shirts. Sometimes it's not on a point. 35 jeans, 41 shirts. 35 jeans, 41 shirts. 39 jeans, 43 shirts. 49 jeans. Oh, 39 jeans, lost my place. 43 shirts. 46 jeans, 39 shirts. 46 jeans, 39 shorts. 47, 47, 47, 47. 50, 39, 50 on the jeans, 39 on the shirts. And for the year 10, 62 jeans, 56, which is right about here. Where am I? Right about there. On the shirts. Okay, so that's, see how it's all scattered all over the place, but do you see kind of a pattern here? Now we've got a couple things happening. This guy up here, he's called an outlier. Okay, because he doesn't really follow the pattern. In fact, if you don't look at him, you can kind of see that it's growing in sort of a, yeah, that kind of method, okay? Sort of linear, but not really. Okay, so correlation, remember, is a relationship that we can consider using a scatter plot. So we're going to look at a relationship in a scatter plot, okay? Remember, we're saying one thing drives the other. There's a correlation between the number of jeans and number of shirts sold. So if you go back to the previous screen, and for you, you can actually see it. You can see where the little dots are. In the scatter plot, we have a relationship. We can have 3 things that can happen. You can have a positive correlation. That means going from left to right, your data looks like it's going up. You can have a negative correlation. Going from left to right, your data looks like it's trending down. And no correlation means you just have a mess. You can't even, I can't go up, I can't go down, I can't do anything. There's no correlation there. I don't see it rising or falling, okay? So for the types of correlation, we are going to assume kind of a positive and negative are the 2 we're going to talk about. The no correlation, we just don't have a correlation. So it might form a linear pattern, okay? If it forms a linear pattern. So what that means, that's what I've got above here. It forms a line in your eye. It doesn't make a straight line. It's not a perfect straight line, but it goes up or goes down in kind of a linear way, okay? So what you have, if it forms a line, then what you're doing is you're looking at the slope. And I'm going to put slope in quotes because it's not actually a slope. It doesn't rise and run on the same exact up 2 over 1, up 2 over 1 kind of thing. It just kind of goes upish, okay? Look at the slope, and if it looks like it's going this way, that's a positive correlation. If it looks like it's going that way, that's a negative correlation, okay? What we drew up here, these 2 things that we drew right here and right here, that thing is called the line of best fit. So that's the line of best fit. Some people just call it a best fit line. It's kind of like a line that goes through the middle. Now, that line goes through the middle, but it doesn't show that it's rising because guess what? That line also goes through the middle. So we have to go left and right. We want about half the points above, half the points below the line, but we're trying to show the trend, the upward trend or the downward trend or the mishmash trend, okay? This is also sometimes called So we can call it a line of best fit, or we can also call it a regression line. Well, line has an I in it. So those are two different words that we can say for it's the line of best fit or the regression line. Okay, they could be linear. So what else we could have, let's look down here at what we've got here. This is a really strong positive because it definitely is going up and it's all smushed together. This is pretty strong and negative. It's pretty mushed together. If you look at these, if I follow them, they're not linear, but it makes a quadratic. It makes a parabola, so that's called quadratic. And this last thing is called exponential, and we're actually going to look at those a little bit later on in this video, okay? It sort of makes a curve going up or a curve going down. So what best describes the relationship between the variables? Is it strong positive, weak positive, strong negative, weak negative correlation? So let's look at what we've got. The ABC company. We have the hours worked and the amount earned in dollars. Wow, that's really small for an old woman. Your eye sees this. That would be a strong positive line, right? Strong positive correlation. What about this next one? Miss Gray's class, age in years and the height in inches. Do you see any correlation really between that? Does it rise or does it fall is what we're looking for. Here, I'm going to say there is no correlation. Okay, it's just kind of, it sort of is like a heartbeat. It doesn't go all the way up or all the time down. All right, so the next one, we've got the age in years and the value in thousands of dollars. Well, what's happening here is it's going down, but it's not really as smushed. See how this is tightly smushed together? The points are all pretty close to that line. These are kind of far away from the line, so we call that a weak negative. All right, it's falling, so it's negative, and it's weak because you can see it goes down, but the points aren't really squished together. All right, the number of customers and the temperature. We don't have as many customers when it's cold. When it gets warmer, we have a lot more customers. So what kind of correlation do we have going on there? It's positive. It's definitely positive, right? But would you call it strong or weak? I would actually call that week. There are some people that no matter what the temperature, we are eating ice cream. And yes, people, I am one of them. All right, Best Buy, number of TVs and the prices per TV. Okay, that was a horrible line. I cannot draw that very well, but I would definitely call that negative. Do y'all call that negative with me? It's going down. And what do you think, strong or weak? I think strong, because look how close those points are to that line. And that makes sense. The more TVs you sell, they can lower the prices of the TVs, right? Okay, what about the Chevy cars? The cost of the car and the gas mileage? It's kind of, I mean, right here I can see negative, but not really, because then I could also go this way. I would call this a weak negative. They do make a declining line, but that's just, there's just too many down below. So I would say it's a weaker negative because there's so many points far away. Okay, the correlation coefficient. The correlation coefficient, first of all, we're going to use the variable capital R for the correlation coefficient. It is a value that shows how close data points are to a line. Okay, and because we're trying to get a nice up line or a nice down line, it's always between -1 and 1. Think about your slope, okay? Don't even look over to your left there. Think about your slope. A negative slope, I'm going to start up here. I'm going to go down 1 over 1, down 1 over 1. It's going to make a pretty nice line with about a 45-degree angle. A positive slope, up 1 over 1, up 1 over 1, makes a nice 45-degree. It kind of cuts that quadrant in half. So that's why we're always going to say, how close are we to 1 or -1? So if we look over here, we're just going to recap. This is a positive correlation, a negative correlation, no correlation. Low negative is the same thing as weak negative. High negative is the same thing as a strong negative. Perfect means they actually make a straight line, okay? Same with our perfect, positive, and high and low. Okay, so if your correlation coefficient is negative, what's that tell you about the slope? The slope of the line is downhill, which means it's a negative slope, right? So that's a negative correlation. If R is positive, what's that tell us about the slope? The slope is rising, and it is a positive slope. If the correlation coefficient is 0, that means there is no linear relationship. Okay, so this would be a 0. Has no linear relationship, okay? So if you look here, this is a low negative, negative 0.3, strong is negative 0.8, that's closer to 1, negative 1 is perfect, 1 is perfect, 0.8 is really close to 1, 0.3 is farther away from 1. So it all depends on how close or how far it is from 1, okay? All right. Now, we are going to graph some exponential functions. So first of all, exponential is going to be a curve. It starts really, really little and it grows up high. It's kind of like mold growing on your shower curtain. You have a shower curtain, it gets one little teeny weeny piece of mold, and then all of a sudden it has 2, and then it has 3, and then blah, 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 they just grow. And they don't grow just one a day, they just grow exponentially. In 6th grade, you did the mold experiment on your bread. Remember, you had a little bit of mold, then you had a lot of mold. So what we are going to do, first of all, it is going to look like this. It's going to have an equation, y equals a times b to the x. What makes it exponential is the x, which is also called the input, remember, is in the exponent. Okay, y is always the output, so it's still y equals. So you're going to have something like y equals 2 to the x. The variable is going to be in the exponent, and that's why it's called exponential functions. The graph is a curve. This one is called an exponential growth because from left to right it's growing. You can also have something that looks like this, and that's called an exponential decay because from left to right it's falling. Now here's what you need to know about this. It will never equal 0. We can't make it equal 0. 2 to any power will never be 0. No matter how small that power gets, you're still going to have a value, okay? To graph it, you're going to make a t-chart. All right, you're going to use -1, 0, and 1 for x, and then you're going to solve for y. So I want to go back to memories. This is remember here. If I take 2 to the -1, remember that negative says I have to put it down on the bottom. It becomes 1/2. Okay, so let's graph one. We're going to graph y equals 3 to the x. Oh, we're doing a whole bunch of points so we can actually see it. So what this means is 3 to the -2. We input that value in x. That means 1 over 3 squared. 3 squared is 9. So at -2, I'm right here at 1/9, just a little bit above 0. Okay, if I let x equal -1, 3 to the -1 is 1 over 3 to the first, which is just 1/3. So at -1, I'm at 1/3, a little bit higher. For 0, 3 to the 0, anything to the 0 power equals 1. So at 0, I'm at 1. If I let x equal 1, that's 3 to the first, which is just 3. X is 1, y is 3. And if I let x equal 2, that's 3 to the second, which is 9. If x is 2, y is 9. 3, 4, 5, 6, 7, 8. Oh, I can't do that. 3, 4, 5, 6, 7, 8, 9. Okay, now when you draw the graph, you want to go through your points. What you want to be careful of is you never hit or touch the x-axis at this point, okay? That'll change in Algebra 2 because you're going to move that graph up and down. But you're never going to touch the x-axis, okay? Now, what x values can we use? Remember, x is called the domain. So the domain is actually all real numbers. We can use any x value in the world. It'll just keep getting closer and closer down here, and it'll keep getting higher and higher up here. The range, which is the y values, that's the range. In this case, it's all the y's that are bigger than 0. Remember, it's never going to touch 0, but it's going to get bigger and bigger and bigger and bigger and bigger. All your y's, whatever x you put in, your y is going to get bigger. That's called a growth. Okay, let's look at what happens if we have 1/3 x. If I take 1 over 3 to the -2, remember that negative says flip it. So it's 3 over 1 squared. 3 squared is 9. So at -2, I'm 1, 2, 3, 4, 5, 6, 7, 8, 9. If I take 1/3 to the -1, remember that negative means flip it. So it's 3 to the first, which is just 3. So at -1, I'm at 3. This is supposed to have a 0 there. If I take 1/3 to the 0, anything to the 0 power is 1. If I take 1/3 to the 1, that just means 1/3. So at 1, I'm at 1/3. And the last one is 1/3 squared. So that's 1 squared is 1, 3 squared is 9, and over here at 2, I'm at 1/9. So if you look, I've got the exact same numbers, I'm just going the other way. So again, my domain can be all real numbers. Every x in the world will work. I'll always have an x value. My range, my y values, if you look at it, my y values are all the y's greater than 0. This is called an exponential decay, and it's a decay because that base, that thing's called the base is between 0 and 1. In other words, it's a proper fraction, okay? So in this last thing, let's review. The domain of an exponential is always going to be all real numbers. I can use every x in the world is going to be there. The range of an exponential, for now, okay, it's going to change when you get to Algebra 2, is going to be y is greater than 0. It's never going to touch 0. This is where y is 0. It's everything above 0. The reason I say it's going to change when you get to Algebra 2 is because you're going to reflect it. You're going to have graphs down below the x-axis, but we're not going to talk about that right now, okay? Okay, guys, this is it. The last video. No pictures, no puppies. Let's draw a puppy. Because I'm pretty sure that's where we started. And we named the puppy, I don't know, what did we name the puppy? Let's call him Paul the puppy. All right, Paul the puppy says the end. That should be a bunny then, right? Hey, have a great day.